Here's a quick lesson on distance. Finding the distance or length of a segment. Graph and then connect. All right, let's jump to finding the distance of AB. Well, the first thing I'm going to do on my scrap graph paper is graph A, -3, 7, and B, 1, 7. I'm going to connect them with my straight edge. And you might have noticed that A and B share the same Y value. Therefore, AB represents a perfectly horizontal line segment. So the easiest way to find the distance of a horizontal line segment in coordinate geometry is to count. From A to B is 1, 2, 3, 4. The measure of A, B, quite simply, is 4 units. Let's try the same with BC. B is already on our graph, so find the distance of BC. C is 1, 4, 1, 2, 3, 4, right here. Here's point C. And you could see that B and C share the same x value. Therefore, you could see that the segment represents a perfectly vertical line segment. And therefore, once again, the very simple method is counting. 1, 2, 3 units. BC is equal to 3 units. So as you can see, horizontal points and vertical points are quite simple to use. However, the distance of AC is really the hardest part here. So I'm going to connect AC, and you can see from A to C is a diagonal. Well, the easiest way to find the length of a diagonal when you have a graph is to use the Pythagorean theorem. Now, the Pythagorean theorem says that A squared plus B squared is equal to C squared, where A and B are the legs, the vertical and the horizontal legs, and the C is the hypotenuse. Well, in coordinate geometry, when we're finding the distance, I'm just going to change the C, the hypotenuse, to a D to represent distance, and I'm going to put it first in the formula. So I'm going to write my distance squared is equal to A squared plus B squared. And furthermore, if I know that my ultimate goal is to find the distance, I'm going to use my literal equation skills that I learned in algebra, and I'm going to solve for D. So to get rid of that square, I'm going to use the opposite force of a square, which is a square root. So I'm going to square root the left side and square root the whole entire right side. On the left side, the square and the square root are going to cancel each other out, and I get the distance, and in this case of AC, should be equal to the square root of the two legs, which is my A squared plus my B squared. Now, if you go back up and look at the A squared and the B squared, that represents the horizontal and the vertical legs. And I can see that AB is my horizontal leg and BC is my vertical leg. So I'm going to come back down here and say the distance of AC is equal to the square root of 4 squared plus 3 squared. The distance of AC is equal to the square root of 16 plus 9, which is equal to the square root of 25. And the square root of 25 is equal to 5. So the distance of AC is equal to 5 units. here. And as you can see, that also is a famous Pythagorean triple, a 3, 4, 5 right triangle. Okay, so let's try that again with this quick problem. Go ahead, pause your video and see if you can find the distance of AB. Okay, let's start out with graphing the 2 points. A, -7, 8, -7, 8. There's my A. B, -1, 2. There's my B. I'm going to connect those 2 points with my straight edge, and I see that it's a diagonal, so I'm going to use the Pythagorean theorem method. As you might remember, that I like to write the Pythagorean theorem method in this form, that my distance is equal to the square root of A squared plus B squared. Well, but how am I going to find my A and my B? Well, again, I'm going to use my straight edge to form a right triangle using AB in this case as the hypotenuse. So I'm going to go to point A, and I'm just going to go down until I'm at the same height as my B point, and then I'm just going to draw another segment across, creating a right triangle, and therefore giving me the ability to use the Pythagorean theorem to find the distance of AB, which would be the hypotenuse of the right triangle. Now, the advantage of having the graph now is that I can just count the 2 legs. So if I count my horizontal leg, it's 1, 2, 3, 4, 5, 6 units. And if I count my vertical leg, it's 1, 2, 3, 4, 5. It's also 6 units. So now I could also use the idea, if we remember our special right triangles, the isosceles right triangle. But I'm going to use my formula. So I'm going to come back to my formula, and I'm going to rewrite that the distance of A, B is equal to the square root of my horizontal leg, which is 6 squared, plus my vertical leg, which is also 6 squared. The distance of A, B is equal to the square root of 36 plus 36, which equals the square root of 72. Now, sometimes when we're doing distance, we do not need to simplify our radicals because we are just looking for either a multiple choice answer, or we're trying to compare the distance of 2 different line segments to see if they are congruent to each other. However, in this case, I'm going to take my distance of A, B, which is the square root of 72, and I'm going to simplify that radical. I'm going to look for the biggest square number, which is a factor of 72, which happens to be 36 times 2. And the square root of 36 is 6. Bring down the square root of 2. Distance of A, B is equal to 6 radical 2. And sometimes this square root of 72 will also be acceptable. Okay, and now finally I'm going to show you what I like to call my hybrid method. How I find the distance of 2 points, or the line segment connecting 2 points, without using my scrap paper. It's not that difficult to do if you are able to visualize or understand the distance or difference of 2 different numbers. I included that little number line on top because that might help some of you visualize the distance of numbers. Well, how do I do Mr. Frank's hybrid method? Well, I write out my formula once again as being distance is equal to the square root of A squared plus B squared. And now, when I rewrite the formula and I'm trying to substitute without the graph, and I get to the A, what I'm really asking myself is how far are the 2 x values of the 2 points that I'm trying to find the distance of? Well, I look at the x of my A and I see it's -9. I'm going to come up here to the number line just to show you, -9. And I look at the x value in my B, and that's +3. And I really just ask myself, well, how far is the number -9 from 3. And I always keep it positive because distance is always positive. And I know that 9 from 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or quite simply, when I have a negative and a positive number, I just add them. 9 plus 3 is 12. And I substitute the 12 to my A. And then I get ready to do the y value. The b is the vertical distance. It's the difference of my two y values. And I have 6 and 1. Well, most of you should be able to do that in your head. How far is the number 1 from the number 6? And the answer is 5. So I substitute a 5 for my b squared. And now I just go on to simplify my radical. Well, we'll simplify what's inside. 12 squared is 144. 5 squared is 25. Put my equal, continue over here, square root. 144 plus 25 is 169. And this one happens to work out nice and perfect because the square root of 69 happens to 169, which is a square number, is 13. So my final answer would be the distance of A, B is equal to 13. And that is all you need to do.